this is not a recipe for success here, guys, because the load that's imposed on the server overall by this 50% telephony software and 50% load generator does not look anything near like what the real world is. It's much less, because these load generators are just lightweight machines for spewing out streams of dial tone sounds. DTMFs are called. That's not representative of the real world level of load. And we got poo-pooed by the developers. Oh yeah, we work on a lot of telephony systems. We know about this stuff. Everything's going to be fine. And look at all the tests are passing. And I say, well, look, I mean, how many performance, load, and reliability tests have you done? Oh, well, we understand the technology, and that's what's really important. Now, there's a passing lesson here I'll point out, corollary, if you will. Performance, load, and reliability testing are very specialized and complex tasks. Something. It's fine to learn lessons, but you want to learn them in safe ways. And what we had going on this project was what I would call careless on-the-job training. Basically, that people were being assigned to do this. And there's no reason to expect that they were going to be able to do this properly. Well, so when we got into system test, we tested differently. So what we did is we had a separate IVR server that was the load generating host, and that was fully spewing out of all the ports load into the system under test. So all the ports are loaded. And as we started increasing the load, then stepping up again, what happened was a big crash. I mean, basically just a little bit over 50% load, and the system under test went over. So, my point about the load generators not being representative was actually, if anything, too gentle. They were almost non-existent. So, the previous slide, that was an example of what's called intrusive load generation, or self-generation of load, and it's just generally a bad idea, because this goes all the way back to Boris Beiser's book, Software System Testing and Quality Assurance, where he said, look, that you don't want to do this because, again, you can't count on the load being created by the load generator looking anything like the load that's going to be created by the software that's ultimately running on the system. So most of the time you want non-intrusive, and if you see someone testing in this unrealistic fashions with a lot of obvious artificiality, then expect the results to be misleading, as the previous slide mentioned. The development test results were quite misleading. Now, I'm not saying don't ever use self-generated load. There can be some times when self-generated load will work. So load and reliability tests actually can use self-generated load in some cases. So an example of that, doing operating system testing on a networked version of Unix that ran in clusters of up to 31 systems. These clusters can consist of either mainframes or PCs or a mix of both. And what we did to try to test these load and reliability test them was we created simple programs that would consume resources. And they were reasonably well calibrated, so we knew how many we would need to fire up in order to consume X percentage of resource. And so we would just fire them up and get to a certain percentage and let the system kind of stabilize a little bit, fire up a few more, fire up a few more, fire up a few more, until we got to the point where we were like 95, 100% resource allocation being achieved, and we would let that run for 48 hours. And because there was some randomness to the programs in terms of what exactly they chose to do, you'd get fluctuation, and you'd get kind of resonancy kind of things. When I say resonance, I mean two things trying to do the same thing or similar things at once. So that can work, and that does work. But for performance testing, definitely you want to avoid that. Okay, testing the tests. Performance, load, and reliability tests are really pretty complicated things. And how do you know you did it right? I've been mentioning things that can go wrong, and how do we have confidence in those? Well, basically what we need to do is we need to test our tests. And the way that we're going to do that is use of models. So you're going to create a model either with a spreadsheet or with a simulation tool, or maybe first a spreadsheet and then followed by a simulation tool, which is the way I've usually seen it done. And what you're going to do, the model is going to give you a prediction of what response time and resource allocation and so forth are going to be in a particular situation. The requirement specification is going to give you an expected result for what that response time and resource allocation and so forth ought to be at a particular level of load, maybe requirement specification and design specification. And then the tests are going to go and test what those actually are, the response time and resource allocation. And if you see that those three things are not aligned, then something's wrong. Now, it's not necessarily possible to say what exactly that something is. It could be that the model's wrong. It could be that the tests are wrong, or it could be that there's a bug in the system under test. But there's clearly something's wrong, and something needs to be looked into further to understand what the source of the discrepancy is. So let me give you an example of this, a positive example. Internet appliance project. We were going to have, at one point, as many as potentially 50,000 of these out there in the field. Now, we wanted to test and know how things looked at 25,000, at 40,000, and 50,000. So we had a production environment. We're lucky enough to be able to use the actual production environment because it was before things went live. And we had a realistic load generator, which was constructed out of pieces of stuff given to us by the developers who had been using these pieces of stuff to do performance testing at the unit level, which more on that later. So we used the load generator to crank up to 25,000, 40,000, 50,000 level of load. And at those levels of load, not only were we checking response time and resource utilization, but we also had people running functional tests in the same environment. The idea there being that this would be interesting to know what the user experience is like when the application when the system is so heavily loaded. And then, as I said, you compare your test results against the simulation results. So here's an extract from our performance